This will be our last example of a circuit rebuild, and we've done this problem before. We've done the reduction before, so I'll go through the reduction step by step, and then I will show you the rebuild. Okay. So in a circuit reduction, we have a combination circuit of R1, R2, R3, R4. We have these in series. Again, this would be in parallel. This is obviously in series with the rest, right? We have our VS is 10 volts, R1 is 10 ohms, R2 is 5 ohms, R3 is 5 ohms, R4 is 10 ohms, okay? And we went ahead and reduced the circuit. Normally, we reduced it for series, right? Then we have the parallel, right? When we got the parallel from here, we got back the series. And then eventually we solve for I. Okay, now we want to rebuild the circuit, okay? So when you want to rebuild your circuit, you got to label all your diagrams because this gets the obviously, you know, this is very, very confusing. So I'm going to take, this is diagram 1, diagram 2, diagram 3, diagram 4, okay? So I'm going to go here, go right here, and write in diagram 1, diagram 2, diagram 3, okay? And you have, last but not least, you have diagram 4. Right. And the diagram 4 is going to be our last one. I'll put a little asterisk beside it. Let me erase the I because the I is kind of getting in the way, right? And I want to make sure, I want to kind of get rid of this a little bit. But diagram 4 is our asterisk, and because it's our asterisk, because that's our last diagram, not our last diagram, but our diagram where it's at its smallest possible state. Okay. And we label this as I. Okay. So once we're at this diagram here, okay, we're going to rebuild our circuit, okay, and we want to just really draw a line across and kind of separate out, okay, and we will now rebuild. So I'm just going to circuit rebuild, okay, and in our circuit rebuild, which is opposite of our circuit reduction, just like this, okay. In our opposite reduction, what we're going to do is we're going to go back to what first? We're going to go back to diagram this diagram 5. This will be diagram 3, 2, 1. So we have diagram 5 will be diagram 3, diagram 6 will be diagram 2, and diagram 7 will be diagram 1. Okay, so we're going to get started now. So here, diagram 5, right? And in diagram 5, I will see diagram 3. Okay. Now we'll just do diagram 3. Okay. Now I'm just going to go ahead and just redraw. And always redraw with stencils, by the way. Do not try to freehand this because you can see this can get messy very, very quickly. So a lot of you have learned, and those who are in my class have learned, that if the work is not neat, it becomes confusing very, very in a short amount of time, and you end up getting their answer wrong. So a lot of you have realized that if you keep the work clean, if you keep it very, very neat, you'll get the answer right, or you can see your error very quickly. That's the objective. The objective is to get the answer correctly, or see the error so quickly that you can correct it quickly. If it's all over the place, there's no way anybody's going to know where the error is. All right. So type in write in VS, R1, and RP. So R1 is here, RP is here. Okay. So first thing we want to do is solve for the voltages across the resistor, and my I is going this way. So VR1 is here. VRP is here. Okay. And so VR1, which is the voltage across R1, is I times R1, right? We've done this before. This is very easy. I is 0.75 amps times R1 is 10 ohms. Okay, this is what? 7.5 volts. Straightforward. VRP will be I times RP, which is 0.75. Our RP value is 3.33. If you look at the previous diagram, our RP value is 3.33, which is what? Which will be, put in your calculator, you know, 2.4975. You can call it 2.5. You can have the decimal, not have the decimal. I just round up to 2.49. It doesn't really make a difference, okay? So the next one will be what? Diagram 6. So if this was diagram 3, then diagram 6 has to be equal to diagram 2. You simply label diagram 2. See diagram 6. In diagram 6, you're going to have the following. You'll have you'll simply copy diagram 2. Okay, so how do we find the current across, right? So first thing you want to do is understand that this current here, right, is the same current here. So this current here is the same current here, which is the same current here, which is the same current here. It's the same current until you get to that intersection, right? So the same current here, which is the same current here and here, is now the same current here. Okay. Now, at this point, when your current has an intersection, when there's an intersection in the current, then it splits. The only time the current changes in the split. Okay? So here is R2 and RS, right? So here, obviously, the current's got to go here, and the current's going to be called I2. I can call it whatever I like. It really doesn't make a difference. I'm just going to call just these values, right? I can call it RS. I'm going to call it I sub S to match this. Right? Or I can call it I3. Maybe it's better just to call it I3, you know, just to be clear. Okay, I3 and RS, weird names, right? So what do? I have to get the currents, then I have to get the voltage, right? So if I have a VR2 here, it really doesn't make a difference until I have I2. And I have a VRS here, none of it matters until I get I3. So I will have to get I2 is equal to I times the opposite resistor, which is RS. RS is R2 plus RS. Okay. This is equal to I is 0.75. You got to keep track of every little thing you do. Okay. RS value, we look it up. RS here. RS, you got to find it, is what? RS is here. Notice how we labeled it? 15. Okay, and this is R2. I apologize. Let me break this back. RS plus RS is R2. Okay, what is our R2? Our R2 is 5. Our RS again, 15. As you can see, you got to keep track of every little thing that's going on. That's the number 15. Let me clean this up. Okay. Now the answer is what? 0.75, right? times 15 divided by 15 plus 5 is 20 divided by 20, I get 0.5625 amps. Okay. I, which is RS, you get R2 is R2 plus RS. Okay. .75. What's my I2? I'm sorry, this is I3. I3 is going this way, going down also, right? I3, and it's going to be opposite of R2. So R2 is what? R2 value is 5 over 5 plus RS again. Here's 15, just like that. So I3 is this. 0.75 times 5 divided by 20. 0.1875. Okay? Now, I need the voltage across all the circuits, right? So let's go ahead and solve for the VR2 and then VRS. So VR2 is I2R2. Okay? And that is what? What's I2 again? 0.5625. R2 is 5, right? Which is what? 0.56. 2.8125 volts. VRS, it's not VR3. VRS is equal to I3RS. I3 goes over RS, and this is 0.1875 times RS, which is, our RS value is 15, okay, which is what here? 0.1875 times 15 is 2.8125 volts. It came out to be the same. That can't be right. Right? Let me see. Split to split. So let me do that again. 0.5625 times 5. 0.815. 0.1875 times 15. It's 2. Oh, it came out to be the same. Oh well. Okay, so here the voltage is the same. Either resistors change, you have a current drop. Somehow it's the same. Okay, so now what we want to do is get this current across the last diagram, right? So we want to write in diagram 2. So I'm going to take this paper off for a minute and type it right in diagram what? Hold on, this is wrong. This should be diagram 6. I'm going to change this. That makes more sense. 5, 6, 3, 2. Right? Okay. Let's go back. We're doing these long videos. It's easy to make mistakes. All right. So last one will be what? It has to be, you're at diagram 6. So now you have to be at diagram 7. In diagram 7, see diagram 1. Okay, so I redraw this circuit. Okay, and we're just going to redraw it. So we'll move this diagram first, right? So we'll take this diagram, right? We'll write in I value here, I2 value here, and I3 going across here, right? If I3 goes across here, this is VR3, and this is going to be a drop of VR4. Okay, so what are my values for VR3 and VR4? For I3, okay, is coming across your series, right? Because it's the same, because it doesn't split. Remember, I's changed because it's split to I1, I2, I3 is the same. So I3 here has to be the same, okay? All right, so what do? I say my VR3 is IR3, which is, I get my I value. This is getting a little messy. I'll take this out. This is my page 2, right? So if I find my I3 value, which is 0.1875, which is here. So 0.1875 here. R3 value is what? My original R3 value is my other sheet of paper, which is 5. Okay, so this is 0.1875 times 5. Erase all this. 0.1875 times 5. 0.9375. VR4 is IR4, which is what? And this is, by the way, this I is I3. I apologize. It's I3, I3. So VR4 is I3R4, okay, which is again 0.1875. My R4 value here is 10 from the original diagram. So multiply that by 10, and I get 1.875 volts. And that's your answer, okay? This is a long problem. So if you look at it again carefully, we're going to go back to our work. We reduce the circuit to here. Then we rebuild the circuit here. And rebuild it here, okay?